Hey guys, welcome back to one of the last videos in the Tetris within Minecraft, creating Tetris within Minecraft series. And in this tutorial we're actually going to go over putting together the functions that we've created over the last few videos and finally making the Tetris game very close to being realistic. And by realistic, I don't mean to say that in real life these blocks fall out of the sky and hit and clear rows. By realistic, I mean they actually, when you place the blocks, they clear the rows like they really do when you're playing the game Tetris. Alright, so let's go ahead and place a couple more blocks here just to make sure that the output is correct. So this row should be cleared and then the rest of the blocks should fall down. Alright, cool. So that worked. Alright, and what I want to try here is I want to try one of the sort of difficult parts of the algorithm, which is where you have like those split rows that need to be cleared. I'll show you what I mean. I'll show you what I mean in a second here, once I get it set up correctly, which is kind of difficult to set up, right? There we go. So we are almost set up for that. Alright, we are going to be go after this. So I'm waiting for an I block. That's a lot of times what the game of Tetris comes down to, is you're waiting for that straight and narrow block to just fit perfectly into that side. And this is actually a case where you sort of see one of the main improvements I could do with this is, in the real game of Tetris, there's a rule that's set up that says that a block can only be spawned once every 6 blocks. So basically you start with a set of blocks and then you spawn one of each of them in a random order. Okay, here we go. So boom, boom, boom. Cool, looks like it worked correctly. Alright, awesome. So I'll show you the output. And the rule that I was talking about is you actually spawn one block of each type in a random order, and then you start over with the next set of each type of block. And just makes the game more playable, because you don't end up with like 6 Z blocks in a row because of the random number generator. But anyway, that's just an improvement for sort of like the follow-up video. Let's look at the code that I've created for this since the last video. Okay, which mainly implements all the helper functions that we've done, like the is row to be cleared and clear row, all those little helpers that we created. So here, the only change that I've made in the game loop, actually the only change that I've made in main is nothing. Actually, I didn't make any change to the main function. The changes that were made started in the game loop, the little game loop test that we made. Only one single change needed to be made in the game loop test, which is kind of cool. It's the function check for row clears after 10 milliseconds. And the reason we had to do this after 10 milliseconds is pretty interesting, actually. It's because if we checked it immediately, it wouldn't register the blocks as being placed yet. I'm not even sure why. I think it has something to do with the server registering those blocks, those new blocks locations and everything, and the material that's actually at those new locations. So it's really kind of interesting, because I wasn't really sure why it wasn't working for a really long time, and then after I did the do function after so many milliseconds, it just started working. I thought it must have been that. Anyways, this is what you want to do. You want to do a do function check for row clears after 10 milliseconds. And we still have to go over the check for row clears, so we'll do that right now. Okay, here's some functions that we've done recently.